There are some reactions in which the rate of a reaction depending on the concentration of substrate and nucleophile. What I mean, the substrate here is alkyl halide and the nucleophile is nothing but the negative group. Nucleophile is negative group when these two concentrations are depending on the rate of a reaction. Those reactions are categorized under this topic SN2 reaction. So, the reaction in which the rate is depending on the concentration of substrate. Substrate is nothing but alkyl halide and nucleophile is shortly represented by Nu minus. Nucleophile is nucleus liking group. Nucleophile is nucleus liking group. Nucleus is a positive center. Nucleus is a positive center. The positive center likes only the negative group. The negative groups are called nucleophiles, nucleus liking group. Philic means like or love. So, nucleus like or love the negative groups. Why? Because nucleus is a positive center. So, nucleophile is shortly represented by Nu minus is nucleophile. So, the concentration of both substrate, that is alkyl halide, and nucleophile depending on the rate of a reaction. Not only that, for those reactions the order of the reaction is 2. It is second order equation. Those equations are called SN2 reactions. SN2 reactions. So, these SN2 reactions are completed in single step. It is a single step reaction. The reacting molecules, that is alkyl halide and nucleophile, they combine and to form the partial bonding and it forms an intermediate. Let us take an example. Minus 2-bromo-octane is taken. Minus before that, let us write the expression. Let us write the expression for SN2 reaction. Here the rate of a reaction is R. Here that rate of the reaction is equal to rate constant K of this second order equation is K2 and the concentration of alkyl halide is square bracket Rx and the concentration of nucleophile is square bracket Nu minus. So, both the concentrations are responsible for finding the rate of a reaction. So, here rate is equal to rate constant K2 into concentration of Rx into concentration of the nucleophile Nu minus. Here the order is 2. With respect to the power of this concentration term 1, with respect to this nucleophile concentration power 1, 1 plus 1, the sum of the powers of the concentration term in the rate equation is 2 and so the order is 2. When the order is 2, then it is second order equation. So, the second order equation and in which the rate of a reaction depends on the concentration of substrate and nucleophile is coming under this topic nucleophilic substitution reaction. So, here for example, let us take minus 2-bromo minus of 2-bromo octane minus 2-bromo octane. Let us write this minus in a bracket, minus 2-bromo octane whose structure is CH3 hydrogen and here N-hexane, C6H13, here central carbon, and this is bromine attached in the second carbon. So, that is the reason why 2-bromo. This is called octane. Why this is octane? Because 6 plus 1, 7 plus 1, 8 carbons, octane. So, this minus 2-bromo octane, when attacked by the nucleophile OH minus, that will attack in the backside of this 2N-bromo octane minus. So, straight to this bromo, or back opposite side to this bromo, this hydroxy minus group attacks the central carbon, that is asymmetric. Actually, this compound is optically active and the central carbon is asymmetric carbon. So, this asymmetric carbon is attacked by this nucleophile. As I told you, this negative group is nucleophile. Previously, I wrote that is shortly represented by Nu minus. So, here this is a negative group attacked in the backside of this minus 2-bromo octane, and it make partial bonding. How? Hydroxy make partial bond with this carbon, central carbon, and the partial bond is formed between bromo and carbon there. Write this CH3 here, and hydrogen and N-hexane. N-hexane is C6H13. This is unstable compound and this is intermediate compound. This unstable intermediate is formed. Why? Because the hydroxy group make partial bonding with this carbon and a partial bond is cleaved between C and Br. This partial bond is formation, this partial bond is cleavage. So, totally OH carbon and carbon Br partial bonding is formed. So, the net structure is this intermediate structure is unstable structure. And in the next step, this bond is completely formed between OH and carbon, and this bond is completely broken and Br minus is released. Here this hydrogen and CH3 are formed as inverted structure. CH3 and hydrogen forms the inverted structure. Here you write this N-hexane, C6H13. So, here this is inverted form, just like an umbrella inverted in a strong wind. So, just like the umbrella inverted in a strong wind, the structure become inverted. The central asymmetric carbon will become inverted. So, inversion of this configuration at a central carbon, that is asymmetric carbon, in a optically active molecule is called Walden inversion. Walden inversion. So, here this minus 2-bromo octane by the action of sodium hydroxide that forms plus 2-octanol, plus 2-octanol. This reaction is SN2 reaction, and this is the proper mechanism for the formation of plus 2-octanol from minus 2-bromo octane. I hope you understand this SN2 reaction mechanism, right?